Hello friends, this is Sasha with Harmony Air, and I want to show you the setup of my Airkrete trailer and share with you the improvements that we made. We always trying to come up with how to make our life easier, and then how to make the installation better, and how to use the equipment in a more efficient way. So today I'm gonna show you the improvements that we did to the electrical part of the setup of the Airkrete trailer, and also the new mixers that we engineered and built. So first I'm gonna show you the electrical stuff. Alright, so let's go take a look at the electrical of the trailer. Here it's pretty much the same as at the factory. We have two sets of hoses, and here is our compressor, and that's one of the things that we added. We added a volt and amp meter for the entire system. So this device, just to know, to make sure it's easier to troubleshoot if there's any type of problems. But if I know that the voltage is coming to the trailer and something is not working, then it's not an issue with the power. I can also see the amperage draw and see that, you know, we are working properly and normally. The pump, just like in a normal place. So what I've done here, the compressor that comes from the factory has this VFG, and previously the power would come into this VFG, and this VFG is supplying power both to the compressor and also those couple of outlets, those two sets of outlets. So I found that to be a problematic thing. First of all, in order to run the outlets, the compressor had to be on. So that's an inconvenience, because before the job begins and after the job is ended, we don't need to run the compressor, and it keeps leaking and just keeps turning on and off. So that was one problem. The other problem was that both outlets were on a same leg of the main line. So instead of getting full wattage, we were actually feeding off the same leg, and we had unbalanced draw, and that was actually creating problems for the obviously for the mixers that we were running, because we would get an overload on one leg. But also it was a problem for the VFG, because it was getting unbalanced voltage. We would have a voltage drop on one leg more than on others. So what we had to do, we actually had to run our mixers, instead of running from those internal outlets, we had to run them through extension cords. So what I've done, from the power that feeding the entire trailer, I disconnected those wires. They were going to that breaker in the back, and what I did, instead of going straight to the breaker, I took those wires and I mounted a panel, a sub panel in the trailer. And now what I have separate breaker for the compressor, and then I have separate breakers for each one of the outlets. Outlet 1 and outlet 2 are sitting on opposite legs. So when we draw in power from here, now we can run anything we want, as long as we are within the total amps. But both outlets 1 and 2 are sitting on opposite legs, and we are not we have a balanced voltage in the system. I also have built and added 2 new mixers, so each mixer has its own 240 breaker, and those mixers are fed by their own VFGs. So this is the power, and here are 2 VFG boxes that I made. There is a reason why I chose to go with the separate VFGs. The reason is I wanted to make sure that each one of the mixers, they're running by the 3-phase motors, because those are more efficient and they take less amps. But I also wanted to have an independent control. So let's say when the main VFG is off, and I didn't want to overload the main VFG. If something happens to the main VFG, then everything stops. We can't do anything. So I separated the compressor VFG from the mixer VFGs, and this way, if anything happens to the mixers, any one of those VFGs, first of all, we don't lose both of them at the same time because they're independent, so we could at least run one mixer. But more important than anything is that we are not endangering the entire operation, and we are not putting load on a main bencho VFG that runs the compressor. Moreover, because we have VFGs for mixers, I can run them individually on independent speeds of each other and independent of the speed of the compressor. Obviously, the bencho will slow down and speed up based on how it was preset for the compressor operation, and that might be different than what we need for the mixers. So separating the electrical appliances from each other, making it decentralized, is definitely a huge advantage and a lot of peace of mind. So I'm gonna close the bencho, and now I'm gonna show you the mixer. So we will go here. Here's one of the VFDs. It's a mixer. I just gave it number 3. It doesn't matter, but that's a number 3. And there are few reasons why I built those mixers, and one of the reasons is the amount of noise that the Milwaukee drills generate. So this is those Milwaukee drills with the just our regular setup Milwaukee drill with the spinners. You can't hear each other when those spin. You can't even hear each other, so they're so loud, and when I'm running 2 mixers at the same time, it's just unbearable. Obviously it's a noise pollution for us, the workers, difficult to communicate, but the other problem is it just creates noise on if we're installing in a residential, we're just making a lot of noise, and you can hear it far away. Another major reason that I wanted to build a mixer is because you can see those Milwaukee drills, they were not designed to do this. They were not designed to mix cement, so they really work in inappropriate conditions. But even more problematic is when we mix in the foaming agent. So now that we're using very hot water, all the steam would come from a barrel up. It would go straight into the brushes of the Milwaukee, and the first time we mixed the foaming agent, we burned a set of brushes. So yes, you can wrap it with plastic bags and all kinds of stuff. It's just not sustainable and not difficult to work. So also the Milwaukees, they do have two speeds of operation, high and low, but they're not ideal. The lower speed is still faster than what we need, and the high speed, we don't even need that high speed. It's the advantage of the Milwaukee is that if it breaks, you can just run to Home Depot and get one very quickly, and so we're gonna keep them in the trailer just for emergencies. But I wanted to get the motor and the moving gears and mechanisms away from steam and away from all the minerals when we put them in the barrels, so it's not only easy to clean, but we're also protecting our mixers, and it's much easier to clean a box than to clean a drill, an angle drill, which it was just in the conditions that were too harsh for it. So for longevity, ease of operation, and more quiet environment, those were my criteria. So the VFG is supplying power to this box. So this is the actual control box. From here we have start and stop, and we also have a potentiometer, and I programmed the VFDs to go from a 6 Hertz up to 30 Hertz. I got quite strong motors, stronger than I needed, so even at half speed they're probably too fast, but I'm thinking a little bit more power is better than less, so they don't work too hard. So again, we have a start, stop, and speed control. So when I go all the way to the lowest, that would be 6 Hertz, and all the way to the highest speed, that would be 30 Hertz, and I can obviously modulate it in between. Let's take a look at the mixer. So this is the mixer design, and what we have over here is this is the body of the motor, where the motor sits, and I'm gonna open it up. So this is a 3-phase motor, just a common motor, so it's not difficult to get replacement, and you know, just a strong 3-phase motor. It won't run as hard, and it will be just easier on everybody. I did make removable covers, and so in case the motor needs access for maintenance or so, both sides are removable. Okay, then the motor is driving as pulleys. So this is the pulley design that I have. The motor is running this pulley, going to a larger pulley to reduce the speed. Even with this setup, the speed is still too high. We could use even a larger pulley over here, but with the regulation of the VFG, we get exactly what we need. Okay, the next big thing is this hopper. So this is really big deal. You installers, you guys know, when you're working with the dry minerals, I mean, this dust just goes everywhere, and if we're working, it just, I mean, we don't want to breathe that, but we also don't want this dust clouds, you know, flying all over the street and getting everywhere. It just doesn't look good, and not professional, and some people wouldn't like it at all. So I designed and built this hopper. This hopper is let me disconnect it. So the hopper is fully removable. I mean, that's, you see a regular bucket. That's just, even if you just had a regular Milwaukee mixer, here's your the mixer itself with the paddles. And then what I did, I just built this hopper, and the hopper has a couple of pins, and it just clicks right in there, like so. It clicks in, and it's all flush over here. So when we mix in, when we're doing the foaming agent, or when we mix in the cement, there's almost no dust coming out at all. And especially when we're doing a foaming agent and we have all this hot water in there, the steam stays inside, and even if it would come out, there's no way any of this dust or steam would make it to the motor. So the motor just always stays clean, and we are not afraid of any kind of brushes burning, which we had on a regular basis. We don't need to clean the brushes in the end of the day. I mean, it's just electrically much better. So what you see on top over here, it's a cover, and this is the access. This is the actual hopper. So the good thing about this is, you can take a bag of magnesium or Magox or talc or whatever we are mixing, right? And we just cut a corner of it and flip it upside down, and now it sits in a hopper. You don't need to hold it in your hands. All of this is made of aluminum. I went with aluminum because I wanted it to be lighter. So that's the setup. So back to our mixer over here. So yeah, here's the hopper. The idea that I have, it's you put whatever stuff you need, and then while it's mixing, you take this cover, and the cover goes over, and this way all the dust stays inside. Yeah, I wanted it to be really, really simple, but effective. So what are my impressions? One of my impressions is that obviously, because I'm using a little more metal in this whole mixer, and also the motor, it's a conventional three-phase motor, it's a little bit heavier. So the entire mixer weighs a little bit more than the Milwaukee setup, but the benefits, the rest of the benefits are definitely greater than this one drawback. So what we'll do now, I'm going to remove the hopper and operate the mixer, so we can just see that it's working fine. I'll just put a couple of screws back into the lid, and you guys will be able to listen to the difference. All right, let's take the hopper off. All right. So very, very simple. Start. And right now we are on a slow speed. And check this out. I'm standing right next to the mixer, taking this video, and there's barely any noise. I mean, if I go on the other side of the trailer, you won't even be able to hear it. Okay, so this is on a low speed, so I'll put it on a high speed just so we can see that it's obviously it's a little bit more sound on a high speed, but it's nothing like the Milwaukee noise. And when we mix in, obviously if it looks like it's too fast, I can just control the speed. It's dramatically less noise than the Milwaukee mixer. So here I go behind the trailer on the other side, and you barely can hear it. So if you have any questions, you're welcome to call me, and I'll be happy to share with you my insights.